Precalculus 6.2 Law of Cosines. So we were using law of sines, but if we are given information where we have three sides of a triangle or the two sides that include an angle, you cannot use law of sines, and so we also have law of cosines. And these again are for when we are solving triangles that are not right triangles. Here are the law of cosines. And so here are those standard forms for solving a standard triangle. Again, standard labeling, we have angles A, B, and C. Opposite side A is little a, opposite side B, angle B is little b, and opposite angle C is little c. And for law of cosines, they give you three different formulas, but what if I labeled the triangle XYZ? You have to really look for just patterns. And so over here we have cosine of A, then it is the side opposite angle A that's on the opposite side being squared. Here we have cosine of B, so it is the side opposite angle B that's being squared over here. And here we have cosine of C, so it is the side opposite angle C that's being squared there. And then the other two sides, which if this is angle A, so we're looking at this angle, then it's the two sides that include this angle that are being used on that same side. So those are just some relationships that you might want to think about as you work through these. And so when we are given the three sides, then we are going to be working with these alternate forms, which are basically just taking each of these and doing the algebra to solve for cosine of A, cosine of B, cosine of C. And then we can do the inverse cosine of the value to get the actual measure of the angle. So find the three angles of a triangle with sides 9, 12, and 14. So I'm going to just draw my triangle. I'm not worried really if it's drawn to scale correctly. I'm just going to use A, B, and C, but then opposite of A is little a, so that's got to be 9. Opposite B has to be little b, so there's 12. And opposite C is going to be 14. And so we can choose really any of the forms up above that we want to. I am going to just go ahead and use this first one and show how it, as I solve for cosine of A, that it gets into this alternate form. So I have A squared is equal to B squared plus C squared minus 2BC. It's that product there, and the cosine of A. So A squared is going to be 9 squared, B squared's 12 squared, and C squared's 14 squared. And I, again, like to think here we have angle A. And so the sides that are including them are what we're using right in here. So I expect that to be the 12 and the 14. And then the value that was of the side opposite it is what's on this side being squared. So continuing, so minus 2 times 12 times 14. And then we have the cosine of A. So if I solve this for cosine of A, and you have to be very careful. Sometimes people think they can do square add, and then subtract that product, but you can't because that 2 times 12 times 14 is being multiplied by cosine. And so you can't combine that to a single value. You could add the 12 squared and the 14 squared if you wanted, but you can't subtract that minus 2 times 12 times 14. That's going to get you in some algebra trouble. All right, so on this, I'm going to move that 2 times 12 times 14 times the cosine of a to the left, so it has a positive value. And then I am going to move the 9 squared to the right. And now I can just divide by that 2 times 12 times 14, and I will have cosine of a. And that is this form right there. And in that form, whatever this angle is, the side opposite is what you are subtracting in the numerator, the square of it. And so we have angle A, and the side opposite it was the 9, and that's what we're subtracting in the numerator, and it is being squared. And then it is the product of the other two sides double that's in the denominator. So that's the alternate form, but we can just start with this one and rearrange it to get to this point. And so we're going to find the measure of angle A here by taking the inverse cosine of both sides. So that measure of angle A is going to be the inverse cosine of this value. And so that happens to be 259 over 336. And we're going to want these in degrees, so put your calculator in degrees and do the inverse cosine of that, and you're going to get, now we're going to use it for other values, so write out 5 decimal places. So that's one angle. You're going to need to do this one more time because you have to get 2 of them, then you can add those up and subtract from 180. So I found A. I'm just going to go ahead and set up for B. Again, to find angle B, I'll use the B squared here, and then I'll have A squared plus C squared minus 2 times their product times the cosine of angle B. And so I've got some different things set up here. And so I'm now focusing on angle B. And so the side opposite is 12. So I'm going to put 12 squared here. And then the two sides that include that angle are the 14 and the 9. So I'll put 9 squared plus 14 squared minus twice their product. And then cosine of B. And then I want this term with the cosine to be positive, so I'm going to move it to the other side. Subtract the 12. And so cosine of B is that 9 squared plus 14 squared minus 12 squared all over 2 times 9 times 14. And if you can figure out how to go and just use that other alternate form, which is this one, and if you can substitute directly into that correctly and be confident with it, you can go right there and you don't have to solve, you don't have to start with this one and solve to that other form. These are nice forms to use when you have all 3 sides, so you can get to solving for the angle a little faster. All right, so then the measure of angle B is going to be that inverse cosine of that value. And again, I'm finding angle B, and the side opposite B is the 12. That's the side that's being subtracted and squared in the numerator. And then the other two sides, the 9 and 14, are being used in the other spots. So then work that out. It's the inverse cosine of 133 over 252. and put that in your calculator and write out 5 decimal places. 58.1445 degrees. And then to find the measure of the third, you can take 180 degrees minus the 39.57122 and minus the 58.14457. And that comes out to 82.28421. You need to practice those on your calculator. Trust me, people make errors on getting those all set up. And then, as always, I want an answer box on those. I don't. Okay. So an answer box where we get to 2 decimal places. Measure of angle A, 39.57 degrees. Measure of angle B, 58.14. And measure of angle C, 82.28. But you have to be careful. You have to use enough decimals that you don't have rounding error on those. And one of the issues might be right here or right here. If you work that fraction out and you only write a couple decimals for it, you won't get your angles accurate enough. So make sure that you're using either exact values there or writing plenty of decimal places out for those. All right, so now, when do we use these? When do we not use? Because we've got law of sines now and law of cosines. And so when to use law of sines? Angle, side, angle. Angle, angle, side, and side, side, angle. And we are not doing this, but just note this: when this happens, sometimes there's something called an ambiguous case where there are 2 triangles, but we're not going to do that this year. And so anyway, so we won't be giving you any of those on the tests. So law of cosine, side, 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 and side, angle, side. That's how you're going to choose whether to use law of sines or law of cosines. These two, you don't have enough information to use law of sines. All right, and then knowing the cosine of an angle, you can determine whether an angle is acute or obtuse, because cosine is positive if the angle is acute, but cosine is negative if it's obtuse. And so as you work some of these law of cosines, you might end up getting a cosine of an angle and it comes out negative. You know that's got to be an obtuse angle. All right, let's go to another example here. Example 2, when you have 2 sides and the included angle. And so when we talk about 2 sides and an included angle, the 2 sides have to create the angle. That is side, angle, side. 2 sides and the including angle. That has to be the setup. And if it's that, you're not going to have enough information to use law of sines, so you're going to have to use law of cosines. So if I set up my triangle, A is 75 degrees, little b is 12, and little c is 10. This is a side, angle, side setup, so you need to use law of cosines. And so when you have this angle, then we're going to work with its opposite side, and we are going to set it up where that opposite side is the one being squared over here. And then it's the 2 including sides that we square and add up. It really doesn't matter which one's first and which one's second. And then it's minus twice their product of the 12 of the including sides, and that is times the cosine of that angle. Follow the pattern rather than getting super stuck on the formulas would be helpful for you. So now as you go to work this, be careful. as I see algebra mistakes. The 12 squared is 144 plus 100 is 244. And then if you multiply that out, you have 120 times 2 is a minus 240. Cosine of 75 degrees. The error that people do is they think they can make that 4 cosine of 75, and you can't. Because multiplication has to come before addition, so this has to be multiplied out before you subtract from 244. This is not 4 cosine 75 degrees. It's the wrong order of operation. So what you want to do on this is just take the square root to find A, and you might as well just put in your calculator just like that. And then you don't have to write down a bunch of values. And check it out. See that you can get that to calculate. It comes, I'm going to write out 5 decimal places because this is going to, could be used in another place to get another value. So you do not want to round it to 2 decimal places there. You'll get rounding error and you'll lose points. So we're going to solve this triangle, and when we solve it, we need to find all missing pieces. So I have side A is 13.48642. And now I need to find one more angle, and then I can add up to and subtract from 180. So I am going to go ahead and set up law of cosines using the angle. Oops. And it's just because sometimes if you switch to law of sines, you can hit the ambiguous case. But, excuse me. So anyway, on this, I'm going to just use the law of cosines where I've got cosine of B. So I'm going to find B. Now, do you remember what that pattern is? That the side opposite that angle is what is going to be subtracted and squared in the numerator. And then it is the sum of the squares of the two sides that create angle B that we're going to be adding up here. So it's going to be a 10 squared plus this 13.48642 being squared. And in the bottom we have 2 times the product of the 10 and the 13.48642. And so the measure of angle B is going to be the inverse cosine of all of that. And you can put in your calculator, but make sure you have about 5 decimal places. And if you get an error, the input to an inverse cosine has to be between -1 and 1. It can't be more than 1 or less than -1. So if this stuff in here is coming to be outside of the range from -1 to 1, you've made an error someplace and that angle won't exist. So I would try to just put that in a calculator. And so I don't, hopefully, yeah. So inverse cosine. But I need to make sure that I go back to the main and change it to we're in degrees. And then I'm going to have a fraction. So I'm going to do that 10 squared plus 13.48642 squared minus 12 squared, and then jump to the denominator here, and I have the 2 times 10 times that 13.48642. So actually Desmos is kind of nice on this, and finish that up. And I'm getting that 59.2. The measure of angle B is 59.25661 degrees. And again, I think I didn't quite copy that right. 0.2566 degrees. And this is probably off a little bit. This even could be off because I used rounded values to obtain that. But it's going to be good enough to get to the angle C to be correct. So now to find the measure of angle C, it's going to be 180 degrees minus this 59.25661 and minus the 75. And you're only going to need that to 2 decimal places, and that's going to be your last calculation. So we can just write it down there and then box in all that you found. To 2 decimal places, the measure of A was 13.49. The measure of angle B, 59.26 degrees. And the measure of angle C, 45.74 degrees. And you can, if you need more examples, if you look for these QR codes and the red problems in the book, you can see video lessons of those. Also in that LarsonPrecalculus.com, the examples there's videos of the examples in the textbook. There's plenty of YouTube videos on law of sines, law of cosines as well. And don't forget academic support.